What's
How's it going? Welcome to Foundations of Programming, day 13, I want to say. Um, Today will be the last day of the week, since tomorrow, um, I have something going on in the evening. I won't be able to teach, unfortunately. Um, yeah, so yesterday we began lesson 11, Big O and Common Problem Solving Patterns. Uh, Cody, were you able to check it out or what's up?
I did. Yeah. Thanks for asking. I watched it. It was pretty good, and I saw that book and I started reading that. And that I like the dude that says it's all about pictures and illustrations. So I think this will be good for me.
Yeah, that book it is wonders, right? It's a I mean you guys saw the comment from Adam as well. He's one of the instructors from Copa-Tune, the program director as well. He really recommends that book too. He really enjoys it. It's a very popular book. Um, it was actually recommended to us by a student in my cohort um that used it to learn data structures and data algorithms. Um, dropped it into our chat as well. Um, and it became very popular. And I've recommended it to many people afterwards. Um, I got other books too, if you guys are interested. Something my class did was it was one of the students specifically that kept track of it all, but she kept track of everything that we would use. So throughout the entire cohort, for everything in class, whether someone recommended this link, this website, or someone recommended this GitHub repo from somebody, or this project, or YouTube videos for any kind of resource that someone had brought up and recommended to the class. Uh, she kept track of all that in a Word document, and then later transferred it over into a public GitHub repo. And it was stuff like books to read, websites to visit, categorize it, websites for HTML, CSS, to practice HTML, CSS, websites for practicing Python, JavaScript, websites to practice SQL stuff, websites to practice everything. And then there was like websites for websites for job applications, websites for uh interview prep. She categorizes all, and then everything that was brought up, anything that was like remotely useful. And at the end of the program, she shared it with everybody. Um, Let me see if I have it. I don't think it's still here. A lot of people left the channel. I still have the Slack channel. Let's see. Uh, Curriculum repo, video reason. We had it all pinned, which is pretty cool. Okay, here we go. I'm gonna share it in the Zoom chat. If you guys are interested in it at all, um, click that link, and it's pretty cool. She transferred it over into a GitHub repository, which was more organized than that. But she had stuff like uniform specific, so don't worry about the uniform specific stuff. It was like our calendar, Excel schedule, like Spotify playlist that we created, uh, a GitHub cheat sheet or a Git cheat sheet, JavaScript. So she has a column for all JavaScript stuff, all Python, all terminal HTML, CSS, regex, personal and career development, books, yada yada. The Python's crash course is in there as well. If you guys want to get it, it's only the second edition, but it's pretty well. For JavaScript, I don't know if the freeware they gave you all of the Eloquent JavaScript book, but in there, um, the manga guide to databases, that's an interesting read. But yeah, there's so much stuff here, you know. I recommend someone does that for you guys. because everyone has tried something. We all learned a different way. So we've all collected different, links, different resources, um, and share it amongst each other. But yeah, so I hope you completed everything, Cody. We're going to pick up the class from where we left off yesterday. Uh, Today we have Zeus today. Nice to see you, Zeus. Um,
You guys,
how's it going? How's it going? But yeah, so we're going to continue. Uh, the assignment that we finished yesterday was I would say frequency counter. Uh, frequency counter.py, and we stopped right before anagrams.py. So we're gonna go ahead and start with that assignment for the first part of the class. Uh, I don't have the repo opened up, but start it, and then what you call it, I'll give you guys about 20 minutes to try get it done and dissect it, and then we'll cover it together. All right, Sam, I'm actually interested in your solution, and then I would like to see someone else's solution afterwards, so we can do a compare and contrast. Sam, would you be interested in showing?
sure. Ignore the comments on top. Yeah, that's it. I didn't like put in the situation whether or not there's gonna be a space because I know is technically like race car like an anagram.
Yes.
Okay, I didn't count for that, but this is the most optimized one I came up with. I did play around with it. I put a if statement, but I was like, wait, why do I need an if return can also give you true or false too? So,
Yeah. Okay.
I'll share.
but yeah,
Wait, that's only going to Sam. That's going to
yep.
see if it's the same backwards. But did you try all the other solutions? Did you run through with like, for example, the QWERTY one, the QWERTY? Okay.
Sorry. Yeah, maybe I thought about something different. So I thought anagram was like literally backwards forwards, and I was like, oh, okay. And then anagram just means like you just switch over all the letters and it equals the same amount of letters in each, right? If that's so, then that I didn't do that right. I totally didn't. I was like, wait a minute,
Yeah,
this is like way too easy.
yeah, you did if it's written the same backwards, which is the
Oh yeah,
palindrome.
that's gonna be a little more difficult. Yep, yeah, okay. I could probably figure that out though really quick. But I like to see Brandon's solution then.
Yeah, let's see it, Brandon.
Okay, so what I did is I set uh, a variable equal to true, and then I did a single loop that will check if a letter is in a string dot lower to avoid any casing issues. And then if that letter is in the second string, I'm going to replace that letter with a blank space, and we're only going to do the first instance of that letter. Otherwise, it'll be false. And then, so we see here, Taco Cat is supposed to be, right, it'll say false because we're missing a T, but if I add a T, it'll give us true. And then we could do the QWERTY. So that's how I came up with the solution.
Your solution. What time complexity do you think dot replace has?
Um, hmm. Probably, definitely higher complexity than.
Isn't it exponential? Because it's like the third nested thing in there. It's checking for each replace. If you put that in there.
Yeah, but I'm only doing the first instance, so it'll
Yeah.
start at the
Yes, but what if it's 1,000
right?
different
Yeah.
inputs and the first instance doesn't come into like input 950? So it would be O if N, right? So I'm just pointing out, right? So the dot replace in your list is O of N. Now, that is within an if statement. What do you think is if letter in string 2 dot lower is doing?
It's looping,
It is
so
looping.
Yeah.
it's O(n) squared then?
Yeah, so that is at this point is O of N squared. And you have that within line 7 where you're looping through string 1. Now, what does that make it?
O of n cubed?
Yeah, right. The time complexity on this is pretty bad. It's not even O of N squared. It's like three loops nested within each other. So just keep that in mind of what you're using. Like it's very simple to want to use something like dot lower and dot replace, but you do want to think about what is it doing under the hood, right? It seems like you would think, oh, I'm gonna use this method to get away from like doing nested for loops, whatever. But you have to take into account that they have their own type of time complexity, and even though we don't see the code, that's what's happening underneath the hood, right?
So how would you do this to keep the complexity as low as possible?
I was
Uh,
gonna say I've got a third solution if we want to look at it and maybe pick it apart. Just
I have a
to see if
one-liner,
it's-
but yeah, let's see if if yours is like mine.
all right.
I mean, it got the job done. Good job, Brandon. But that I'm actually glad you shared that because it brought up that discussion.
So
Yeah, go ahead.
it should see my screen. I had to resist the urge to kind of solve it in a similar way Brandon did. And I actually modeled this out after the solution we came to yesterday. I don't remember that problem, but I know we used two dictionaries and kind of compared the values across both of those. And there was also sort of the same edge case that I wanted to cut off there. So first compare the lengths of the two strings. If they're not the same, they can't be anagrams. Then I defined two dictionaries and then essentially converted the values in those strings and came up to a count and put those into the dictionaries. And then I directly compared those two dictionaries and seemingly got the correct answer down here. So yeah, I don't know. Is this good or bad?
That's really good, right? And I'm glad you did it this way, Eric, because the slides are in the sequence that they are, right? We're not going to teach you a type of problem solving pattern and then give you an assignment that doesn't even implement that pattern, right? So the goal is, right, which it was an implied goal was to use the pattern that we just taught prior to the assignment and then kind of use that to solve the assignment. So I'm glad you did it this way. But yeah, so what we just learned before with using the dictionaries, that worked here too, working with two different lists, right? And using the dictionaries, because dictionaries have the key value pairs allowing you to access it directly with the key. Whereas the list we're having to loop through, right? So good job on you. That is a much better way. And I'm just saying, Brian, I don't want you to get like insulted. Good job.
I'm
Like,
so offended.
like I'm glad that we get to see three different versions of how it can be done. How to do it when you don't read the problem like Sam, or right, or when you use these methods, right? Just know that what these methods are doing, under the hood, they're doing a lot of for loops, right? It's O then a lot of times. So just be aware of that. But cool. All right, so moving forward,
Hey, Sir, Roger, real quick.
what's up?
So what is this? Is his just O of N? Is that his running time? His big
Yes,
O?
it is just O of N. Big O
Nice.
notation is going to be O of N. N being the number of inputs iterations because of the for loop, right? The for loop.
Damn.
The line 9 where we're doing if L in dict1, that is instant, right? So because of the dictionary, so pretty cool, right? We go ahead and move forward.
Really quick question. Does
Yes.
do variables count towards like the ON calculation? Because if you have like 4 variables, is that kind of like the same? It's only for like nested loops when it becomes like exponential, right?
Are you talking about the
Like if you declare a variable,
for space complexity and when it
Yeah.
comes to variables? It's what's being stored in the variable, right?
okay.
Right.
So if
you
it's just like a list, it's just like, okay, cool, like that's just +1, vice like times itself. So not too much time added.
these so don't worry about that. That's not going to affect assigning a variable will be instant. When
Okay.
talking about space complexity for variables and stuff, that's a little bit different when we're talking about what's being saved in there. But yeah,
Mhm.
so variables is instant.
Okay, cool.
No problem. All right, so we just covered anagrams.py. Next, we're gonna move on. Multiple pointers pattern. This is a very popular problem solving pattern. This pattern is going to consist of creating 2 pointers that correspond to an index and move towards the beginning and or middle of the string or list based on a certain condition. Are very efficient for solving problems with minimal space complexity. Why is that? Well, because typically on the for loop, we would loop through the entire array or list until we reach a certain point. But by using pointers, we're able to cut it ideally in half, right? Because we're starting from both sides and working our way toward the center, depending on certain conditions, whether it's on the left or the right, until we find the solution, right? Multiple pointers dot py. So okay, give it a try. It's kind of throwing you into the deep end. For multiple pointers dot py. Let me see if it didn't hear. Oh, okay. I don't want to show it. Here's my answer for the anagram one. I got 2 lists. They're both sorted. They're not nested sorted. So this is still just O of N, and then I did a comparison. I stripped any spaces, sorted, and joined together on one line. So another way of doing it, but it wasn't using the algorithm that was taught in the slide. So technically, Eric, you did a much better job than I did. But yeah, so for the slide, the multiple pointers one, you're gonna write a function called sum0, which accepts a sorted list of integers. The function should find the first pair where the sum is 0. All right, so you're gonna return a list that includes both values that sum to 0 or -1. If a pair does not exist, you return the -1, right? So essentially, the way it's describing it is you're going to grab the list, you're going to declare different values, one being the start and one being the end, right? Those are your 2 pointers, right? The start of your start pointer will be obviously whatever is in index 0 of your list, and the end will be at -1, right? Which will give you the last index in your list, right? That'll give you the last value. And then you would begin, right? So you would do for I in a range of whatever the length of your list is, right? And then you would run through the first iteration. You would check if, the if you add the first pointer and the second pointer, what does it give you? Well, if we're trying to find if the pair sum is 0, obviously, if we add -3, let's get a better one. -10 and 99, right? If we add it, what is that going to give us? It's going to give us 89, and then we'll move our pointer to the left, right? And then we'll check the sum of -5 and 99, right? And if it doesn't give the answer, we're going to move the point to the left. We're going to do that all the way until we reach the end pointer. Well, if we didn't get the answer, then obviously -10 did not work. So the start pointer will move up to -5, and this time we will do correction. If we move the start pointer all the way to the end and that didn't work, well then now we're gonna check the end pointer. So we'll move 99 to 87 until we reach the start. If none of these combinations worked, then we're going to move our pointer to the next one. And we're gonna do the same thing too. We're going to check if the sum of -5 and 99 equals 0. If it does not, we'll keep moving until we reach the end pointer, and then we'll do that with the end as well. We'll move 99 until it reaches -5. If we still haven't found the sum, then we'll move the start to 0 and do that over and over again, right? Until we've gone through the entire list and check the sum of every single integer's sum until we reach 0. That is essentially what your 2 pointers is doing, right? Having multiple pointers. So give it a try. There is solutions in the slide if you want to cheat. Try not to cheat. Try and kind of figure it out yourself if you can't. But we will cover it afterwards. Right. So you kind of see that here. We have a start and the end. They're moving the end pointer to check the solutions. If it doesn't work, then they're just going to move the start and end within the loop. Right. And you do it until you go through every single item within your list. Cool. Multiple pointers out pi. Try it out.
I feel like this one's gonna be one that might be
Yes. How do you know you can use this method to solve this problem? The keyword is in sorted list, right? The list, it is sorted. So that means from left to right, it goes from least to greatest. So if you add what's an index 0 to what that index -1, and it's greater than 0, what does that mean? Well, your far right pointer, your end pointer, is way too high of a number. So therefore, you're going to move the right pointer to the left, right? You're going to check the sum of that again. If it's still high, you're going to move the right to the left because you have to decrease. You want to find a smaller number until you reach the value of 0, right? If you do that all the way to the end and it's still too high, that means your left pointer, whatever your start pointer is, was way too high as well. So then you're going to move the left pointer to the right and then restart that loop again. So you're going to do that until your left pointer reaches the end pointer. Does that make sense? This method only works because it is a sorted list. Does that make sense? So if the list is going from 1 to 10, and we're trying to find the number 5, right? Our start pointer is index 0, which has the value of 1. The end pointer is at index -1, which holds the value of 10. We're trying to find the sum of 5. You know, which two numbers added together is equal 5. Well, that's going to return to us 11. So obviously, our end pointer is way too high, so we're going to decrease it. And now our end pointer is at -2, right? Which will be 9. What we check the sum? Well, now it's 10. It's still too high. We're going to keep decreasing it, right? it's going to return to us the value. The first time, the first two values that are equal 5 is going to be once that end pointer reaches index 5, because that'll be the number that has 4 in it, right? That'll be the first time we find it. But in the event you don't find that, you would have to keep moving your left pointer upwards. Does that make sense? Right, so it only works because it's a sorted list. Hopefully that helps you guys out when setting your conditions of when to move your pointers. That's the only hint I will give you.
Can I have a little bit more time?
Yes, go right ahead. All right, we're gonna go ahead and start. So, the multiple pointers, right? So we had a created function called sum0, which accepts a sorted list, right? The keyword there being sorted. All right, the function should find the first pair where the sum is 0 and return a list that includes both values that sum to 0 or -1 if a pair does not exist. All right, so the multiple pointers gets its name from the fact that has two different pointers that we're going to use to keep track of our progress. So we're going to go ahead and clear our left and right pointer, right? And it'll be, for the left one will be sorted list, will be 0, comma, sorted list, -1. And this will assign two variables, one to the left and one to the right. Actually, correction, it'll be 0 and -1. Or essentially the length of sorted list. And then because of the index, we would have to do -1. All right. Because we don't want the value, we want the actual position of where it's going to be at. So it's going to be 0 and then 1, 2, 3, 4, 5, 6, right? Whatever this is. If we took the length for a list, it'd give us 7. So this will give us the left and the right of our list, which will allow us to manipulate what number we're working with. So next, it's going to be the one and only loop that's going to allow us to do all this. And it's going to be a while loop. We're going to do while left is less than right. Then we want to do something, right? As mentioned before during the explanation, we start from the left and from the right, and we're going to do something until we reach the max of all the or the quantity of values that we search through. All right. Once our right pointer reaches the left or the left reaches the right, then that means we have nothing else to check, and we're going to move forward. So while that's happening, we're going to do current sum. All right, current sum is going to be where we're going to check if we have 0 or not. And then we're going to grab our sorted list. We'll grab our left pointer plus sorted list and our right pointer. All right, our current sum is going to be the sum of where we are starting. All right, it's going to be the left and the right. We'll add those two together. And which call it, if those two together will end up returning to us 0 if the sum was 0. Oh, we're returning a list that includes both values if the sum is 0. All right. So that does that, and then we're gonna do if or else checks, right? So we're gonna do if current sum is equal to 0, then we want to return the list, right? So we'll do sorted list left for the first item and sorted list right for the second item. That'll be the list that we will return if the sum is equal to 0. Right, that'll check the very first one, and then we will check the remainder. So we will do elif, which call it current sum is less than 0. So if we add -2 and 3 and does not equal 0, then we should be able to move on our pointers, right? So if it's less than 0, that means our left pointer is way too small for it to reach the outcome that we want. So that means our left needs to move to the right, right? Because in this example, we have, let's say, 1, 2, 3, 4, and 5, right? If we want to find which the sum of, what you call it, two numbers that equal to 3, our start's 1 and our end is 5, add them together, it's 6. Obviously, it is too high. So 1 needs to get bigger to see, or sorry, 5 would need to come lower because we're trying to find the sum of two numbers that equals to 3. So if current sum is too high, then we would move our endpoint to the left, right? Because it's way too high. We want to keep finding the number that equals the outcome. And 5 plus 1 will be 6, and it was way too high for the number that we're looking for. If it was too low, right, then we would have to move our left to the right. Let's say this was like -10, right? And then this is -2 and 3. All right, let's say we're trying to find the number that is equal to 2. Well, if we're trying to find which two numbers added together is equal to 2, when we add -10 and 5, that gives us -5. Therefore, it's way too low. We're trying to find which sum is 2. So that means we would increase the left pointer. Left pointer will move to the right. All right, then we would add -2 and 5. That will give us 3. So obviously that's not what we're looking for. So we will move -2 to 3. And then -3 plus 5 would be 5, 6, 7, 8. So that means it's too high. At this point, we've already went past the combination. So what do we have to do? We would have to move the right pointer to the left. All right, and then we would restart the left pointer. The left pointer would come back over here. We would check 4 and -10. That gives us -6, way too low. So we would move the left pointer to the right. And now we're checking -2 and 4. What's the sum of that? Well, it would give us 2, and we find the answer we're looking for. So that's kind of how the left and right pointers work. They're checking the combinations from left to right and moving towards the center, right, until left is while left is less than right. That means we're still having to check combinations. If the left pointer is now equal to what the right pointer is, that means we've ran out of combinations and we can stop the loop. That's what the while loop is doing. So with that in mind, if current sum is less than 0, that means our left pointer is way too small. So we would do left plus equals 1. All right, and that would move our pointer to the right. Else, we would do right minus equal 1. And we're going to keep doing that until we find the sum that's going to give us 0. Now, in the event this never stops, once the while loop ends, if we have yet to return a sorted list, that means we never found the combination, and we will return 1. Then we are able to do this. CD lesson. Oh, CD P lesson 12. CD multiple pointers, and then Python multiple pointers. All right. And we see here -3, -3, -5, -5, -1, and -1. So it returns to us the answer that it's supposed to return. Cool. Awesome. Let's go back to our slides. So multiple pointers.py, a not so great solution, right? So here we have a nested for loop, right? They do for I in range of whatever the length of this list is. And then after that, they do a nested for loop for j in range of I plus 1. So whatever I is, we're going to start to the number afterwards. And then to the remainder of what the list is. and they're checking the index from the first list, from the first for loop, and the index from the second for loop, right? So essentially it's doing the same thing we were doing, but they nested them together. That's not what you want. All right, that increased the time complexity to O of n squared, which makes it very inefficient. A better solution was to create the left and right pointer. Right, same thing that I did with the left and right, just they made it into two different lines. One starts at the beginning of the list, one starts at the end of the list. They then begin their for loop. They have their total. If total is equal to 0, then they're going to return that list the same way I did. If not, then if the total is greater than 0, obviously they have to move the right pointer to the left. And if it's not, that means total was less than 0, so they had to move the left pointer to the right. Cool. And that's how the multiple pointers work. Unique values dot high. This is going to be correct because we have yet to go into another pattern. It's going to be another multiple pointers assignment. So give that bad boy a try. All right, we're gonna go ahead and start. So we have to write a function called count unique values, which accepts a sorted list, counts the unique values in the list. There can be negative or positive numbers in the list, but it will always be sorted. All right. Once again, the keyword in here is the fact that it is a sorted list, which let us know that we're able to use the pointers method, right? So we're going to define count unique values, and we're gonna pass an R. I hate typing sorted list over and over again. Now we see here as well as an example on line 8 that there's a chance that we might receive an empty list. So we can say if R, if not R, return 0. Right. So by doing the not, it's going to check if it's an empty list or not, and it'll return 0 right off the bat. Next will be, what if the list only has one item in the list? So if length of R is equal to 1, return 1, because there's obviously only one unique value in there. And now we can actually do the functionality here. So like before, we're going to use our left and right pointer. So we'll say left, right is equal to 0 and 1. All right, so this is going to be a little bit different. So although it uses both pointers, we're not going to start on both ends. We're going to start on one side of the list, and we're going to move our way to the right. Then we can do unique is equal to 1. We'll take into account the very first item that will be in the list, and we'll say while right does not equal to the length of our list, then we should be good, right? So if we're looking on line 5, if right starts at 1, 2, 3, 4, 5, as long as it's not equal 6, then we want to do the while loop, right? Because it'll reach index 5, but if we try to run this, if we put the wrong length here, then we'll get some weird value, or it actually will get an error because it'll say it's like out of the range of the list length. So we're gonna try to do up to the length of the list, because the length of the list is 6. We don't want to get to the length of 6. So as long as not the length of the list, we should be good to loop through it. So we'll say if R left, right, whatever index is for left is not equal to R right, and that means we want to move our pointers to the right. Then we would say unique plus equals 1. All right, so that means if whatever is in index 0 does not match with the index 1, that means they're unique, right? Because they're not the same. So we should increase our unique count. And then we're going to say left is equal to right. All right, so we'll move our left pointer to the right, so we're done checking that number. And then we can also add a different one. We'll say elif if left is equal to what right is, then right needs to move to the right. Right, so right plus equals 1. So if we start at 0, 1, it's going to check, hey, does R left, whatever is in index 0, does that equal what's on index 1? It does equal the same. That means it's not a unique value. So we need to shift the right one over, right? So left will stay at 0. The right will go to index 2. It's going to check again. Hey, is 1 the same as is the left the same as right? Yes, it is. So we don't have a unique value. That means we need to move the right pointer again. The right pointer now becomes index 3. Hey, is index 0 the same as index 3? It is. I'm going to keep doing that until it reaches the last item in the list. It's going to check, hey, does index left equal the same as index right? No, they're not. Therefore, we'll increase the counter up by 1. So this will return 2, right? Because we started with a unique value of 1. Here, if we were checking the second one, right off the bat, we start with 1 unique value. We're checking right off the bat if left is equal to right. If it is not equal, so the unique counter goes up to 2. Left is now equal the same as right, so left is at index 1. It goes to the list. It's going to check if left is equal to the right. Well, it is, so it'll push the right to index 2. And it's going to keep doing that all the way through until it grabs all the unique values. And then at the end of it, we can just do return unique. So let's go ahead and copy and paste the test case. And we can, why does it look so weird? There we go. That was weird. Run it, and we see 2740. That matches our results. Cool. So we still use the multiple pointers, except of starting at the end. We started on the left side and just shifted it over and over again. Sound good? Did this make sense? Who wants to share their solution? No, Eric?
So mine's pretty much exactly the same as yours, except I just did one thing. I got rid of one if statement.
Okay,
So I didn't do that at all. I just used the dictionary.
a dictionary. Okay. That works too, because unique values.
I did pretty much similar. I was just trying to do like a while loop as well, just trying to figure that out. But the if statements look pretty similar to what you just did.
I want to see a dictionary. Can I see the dictionary? I believe that was Joseph speaking.
Yeah.
Yeah, let's see how you did the dictionary one.
So just initialize an empty dictionary, loop through the list. If the value already wasn't in the dictionary, added the key and then set it equal to 1, and then incremented it as it looped through the list, and then just returned the length of the dictionary.
Yeah, that is the power of dictionaries. That is so nice, right? You guys see that? Not what you should have done, but it is a way of doing it, and a really good way too. So props to you too, regardless. But awesome. So that's another way of doing it. Cool. Who has something different? I think Brandon. You want to share yours, Brandon?
Yeah, so I tried doing it with the binary search afterwards. Because but basically, I used one line to So I took the length of sorted list cast as a set. Um. So that should return 2. Yeah, so basically, sets can only have unique values, kind of, like dictionary keys. So basically it iterates over the, list once, and then, taking the length of that gives you the unique number, unique count. So it's still O of n complexity, but you're not using, the binary searching.
Cool, huh? Another way of doing it. So all these methods will accomplish the exact same thing, some with more code or less code, with pretty much the exact same efficiency. And it's just nice to see different ways of doing it. Awesome. The point of
So
this class, go ahead, Cody.
yeah, so real world, like the complexity is the same, right? So what delineates? I know space, right, was the other one, space complexity, but that seems to be about the same too. So like, I guess in this case it would be comprehension of code. Is that where we're like diving down into, or what's
Yeah.
the big picture there?
So if you remember the one of the slides, like, oh, what makes code better, right? There's 3 questions. Is it, the time complexity, the comprehension of it, how neat of it was and whatnot. There's many factors that goes into it. First and foremost, ensuring that you're taking the time complexity into account, and then afterwards ensure that it's nice and neat, readable, and then space complexity at the end of it. But if you can hit all 3, those are the things that should go through your head as you're coding. Like, how fast is my code? Is it efficient? Right? Is my code being efficient? Do I have nested loops? Can I use a dictionary instead of looping through? Is there a much easier way of going about this? Mine looks a little bit too complex, right? Even though it's not really complex, right? But when you look at all that, you're seeing, okay, I have a left and right value, unique count. I'm checking if they're not equal, like reassigning left and right. Like, it can get very confusing if you've never seen pointers before, right? Whereas if you were to use a dictionary, I think, although this is very simple too, if you didn't even think of this method, Joseph's method is pretty freaking clean, right? I think you can really visualize pretty easily a dictionary and how you're assigning keys and values. So that's a very nice way of doing it too. So after you write your code, you ensure it's efficient, or ensuring that it's neat. Is it too much? What is my naming conventions looking like? Is it confusing? Does it match the content or the context of my content? So a lot of questions to ask yourself, but that's kind of how you essentially will dictate how your code should look like. Those are the questions that you ask as you code along, right? But either way, all 3 methods, good methods, right? Both of them have their pros and cons. Some are longer, some are a little bit more complicated, some are simple, straight to the point. Yeah, cool. As I was saying earlier, the point of this class isn't to make you an expert at problem solving and knowing all these different methods. It's to just give you some tools for your tool belt. So when you start going through these LeetCode problems on your own, like, you're not as lost just trying to code stuff, seeing which what bites. At least now you're be able to go in there with game plans. Like, all right, okay, so it's a sorted list. I know sorted list. What can I do for sorted list? Pointers and whatnot. I know dictionaries can help me keep count of the frequency of different stuff. You start having things in your toolbar that you can use to solve these problems. But yeah, that's the whole purpose of these classes. Time is 7:27. Let's go ahead and come back at 7:37, and then we'll work through the last hour of class. All right, we're gonna go ahead and pick up from where we left off. It's pretty consecutive on these slides, so we'll go over the next pattern. And that's gonna be your sliding window pattern. So this pattern involves creating a window, right? It's a makeshift window which can either be a list or a number from one position to another. Depending on a certain condition, the window will either increase or closes. By increase and closes, we mean in size, right? So it's almost like creating a sub list within a list. So you have your list here from one to, to a random number. They're not sorted in any shape, way, or form. And we're trying to find either some kind of pattern or something within here. So we create a variable that's going to hold a sub list of our list, right? This list is 5 numbers long. It starts from the beginning, and then depending on what the condition is, this window will either increase, decrease, or slide to the right and whatnot, right? It's very useful for keeping track of a subset in a list or string. Sliding window, let's check it out. Yep, good. So right function called max sublist sum, which accepts a list of positive integers in a number called num. The function should calculate the maximum number of n consecutive elements in the list. All right. Essentially, we're trying to find what the max sum would be without using the max command on here, right? Or something crazy like that. So essentially, the window will start here. For example, on number 1, we would grab the first 2, see if it's how big it is, whether it's like, add it up. It says 2 and 1, that's 3. We increase the window, it adds 3 numbers. We see what you call it, 1, 2, and 5. So 5, 6, 7, 8. We increase it, and we go into 10. What else? Let me see it. I haven't used this in a while. Right function called max, which says list of positive numbers, and a number called num. All right, so the number we're gonna get here is gonna be 2. So 2, 4, 1, and 4. Right, so that's how big our sliding window is. We want to find what's the maximum we get of 2 consecutive numbers back to back. So essentially we'll do 2 and 1. That is 3. We will slide the window to the right. We took that previous sum, which is 3, saved it in a variable, right? That would be like our current total or our max sum at the moment. The next time we slide that the next window, we're going to check these 2 out. Well, if it's 2 and 5, that gives us 7. Is that greater than our current sum? Then yes. So we would keep track of what this pair would be. It would be 2 and 5. We go to the next one. 5 and 2. It's still the same.
Roger.
What's up?
I think I might have missed something, but I might have missed something you said earlier. It says n consecutive elements in the list.
Yes, n being that other number being given here.
Okay.
Right, so we have it's taken in 2 arguments, right? One's going to be the list,
Oh.
and the second argument is the n, right? How
Okay,
many,
copy that.
consecutive, right? So we want to get the maximum of 2 consecutive numbers within here,
Nice, thanks.
right? So this gives us 7. It's still it's bigger than what it was prior. The next one is still 7, so the maximum we can get is 7. The next one in the next window, as we slide to the right, would be 2 and 8. That gets 10, right? So that's so far it's going to be the next new maximum that we can get within this subarray of consecutive numbers, right? Which is why we're not increasing or decreasing or changing what's inside subarray. Just consecutively, we're sliding the window to the right. 8 and 1, that's 9. So that is not greater than 10. And then 1 and 5, that's 6. So the maximum we got was 10. So we slid that window all the way to the end of it until we got what the max sum was, which for this one was 10. Here for consecutive numbers, we are taking a window of 4. So we would start here. So 1, 2 is 3, plus 2 is 5, plus 5 is 10. So the sum on the first window here is 10. We slide to the right. We see that this gives us a new sum. So 8, 10, 15, 16, 17. So this combination numbers gives us 17. So that's a new max sum. So we would change the current sum to 17. We slide the window again to the right. This gives us 8, 9, 10, 11, 16. It does not beat 17. So we keep the current max sum. Slide it to the right. The end of this window finally reaches the end of the array. We check some of this. It's 16. Still does not beat 17. Right. So the loop should stop there because we reached the end. The window reached the end. And we return the max sum, which was 17. Right. That's going to be your sliding window. So give that bad boy a try.
Is there a way to solve it without a nested loop? I presume there is.
There is.
Okay.
All right, let's go ahead and check this out. I'm gonna go ahead and share my video. For the most part, were you guys able to get pretty far? Maybe not finish it? Who did finish it?
I finished it.
Okay. You're really catching on to this stuff, Cody.
Yeah, I mean, it's basically, I didn't get the first ones, but after you showed it, it seemed like a pattern. So I'm using the same stuff that we did initially and just
Mhm.
iterating it.
Okay. All right, so we're gonna have to write a function called max sub. Define max sub list sum, and it's supposed to accept a list of positive integers. So list of positive integers and a number called num. Right? The function should calculate the maximum sum of n consecutive elements in the list. So we'll go ahead and start this out. So we already see here on line 9 that there is a chance that we're going to receive an empty list. So we should probably take care of that edge case. So we will do if the length of list of positive integers is less than num, then return none. Right? So right off the bat, that should take care of the none one. And in the event that it doesn't even reach the quantity of what num should be, then it'll return none, right? Sorry, give me a second. My girl is messaging me. All right. So we took care of that edge case, whether it's an empty list or if it doesn't even reach the length of what num should be, then we'll just get none. Then we will do we want to grab the current sum that we will have for the window. So the window will be just as long as what num is. So we're going to do max sum is equal to sum list of positive integers. And then to get the length of that subarray, we'll do start will be with nothing. That means it will start from the very beginning by leaving that value empty. And then we're going to get up to what num is, right? So because of index notation, we want to grab the first 4 numbers. This will return up to, but not including the right number. So it should return 0, 1, 2, and 3, right? That'll be the max sum for our first window. And then we're going to declare a current sum value, which is going to allow us to keep track of the working sum as we go through our list.
Forgot a
Oh,
colon. It's causing
My
a break.
bad. Yep. Thank you, thank you. I'm a little distracted. My girls bring me food.
Line 5,
Line 5.
end
Yep.
of line 5.
All right. So this should keep track what the current maximum is. We're gonna need a working variable as we loop through this list. So now we can actually begin the loop process. So we're gonna say for I in range. And here's where it gets a little bit interesting, right? We don't need to start from the very beginning. We're gonna want to start from wherever num is, because we grab the window. The window starts here, but we want to loop through the remainder of the list. Num is, for example, here, let's say it's 2. So we don't want within index 0 and 1, we want what starts at 2, right? So it should start at range of num, and then I want to end it up to the length of whatever my list is, right? After it reaches that point, it should stop automatically. That way we don't get an error that it went out of range or anything crazy like that. Now, as we begin our for loop, we're going to do current sum is going to equal, and this is where we're going to do most of the functionality, right? The current sum is going to be current sum minus list of positive integers, and the index we're going to grab is going to be the very first item inside of what's supposed to be our window, right? That's going to be I minus num. So what that's doing is by grabbing the first item, right? This returns index 0, y. Well, I is technically, if we're using, let's say line 6 as an example, I is going to start at, what you call it, at 4, right? So 0, 1, 2, 3. I'm sorry, it's going to start at 3. Nope, it starts at 4, right? Because num is going to be 4. So 4. So it grabs index 4. It subtracts what num is, which is 4. So 0, 1, 2, 3, 4. 4 subtracts I. So it should give us index 0, right? So it will drop the first number, right? We're gonna drop the number on the far left. So whatever I is, you subtract num, and it will drop the first number. Once I goes to the first iteration and I moves up to being 5, it'll be here. 5 minus 4 will give you 1. So that means the next time it drops another number, it will drop the next one. It's supposed to be the start of our window. When I becomes 6, 6 minus 4 will become 2. So it'll drop the next item in the window, right? So it's dropping the far left number, right? And by doing current sum minus that first number, we're essentially subtracting it from our window, if that makes sense, right? But after we drop the first number, we want to add the far right number, so plus, and then we're going to do list of positive integers, and it's going to be I, right? That'll grab the current number that we are working on, which will be on the right side. So subtract the far left number and add the new number, right? That current sum is the sum of that window that we are actively working on, right? And now we can do a compare. We'll say max sum is equal to whatever the max is between the current max sum and current sum, right? It's going to grab what we declared before, which was the max. It's going to grab the new current sum. It's going to see which is higher. And it's going to save that into the exact same variable called max sum, right? And then we can just return max sum. Because by the end of the for loop, it would have gone through the entire list, grabbed whatever the max was, and then returned it for us. We can go ahead and copy our examples, paste them, and then run our sliding window. We see we get 10, 17, 6, 13, and none. Cool. Did this make sense? Anybody?
I
Anyone
think,
confused?
I'm starting to feel like I need to, like, obviously I need to study more about, using the least amount of complexity, when I'm writing code. But at the same time, I do feel that I'm trying to put too much emphasis on like not using loops. And I need to, maybe not weigh so heavily on this, is the first thing that comes to mind.
I
You
kind of fall in
can.
the same boat as Brandon there.
You're
I feel like-
able to use loops. It's okay to use loops, right? You want to avoid nested loops, but sometimes like you have to use nested loops, right? Where it becomes an issue is when you have a nested loop within a nested loop. That's where like it's no. You want to avoid oven cube, right? Oven
Gotcha.
square is not too bad. Like if you have to, that's fine, right? There will be times we have to. Like they're common to use. Cube is where you start getting where like, okay, you might want to find a better way of doing that. All right, a nested loop is not bad. I feel like I gave you guys the wrong impression. Is that a preferred method? Of course not, right? We always want to make it as fast and as efficient as possible. Sometimes the problem calls for a nested loop, and that's okay. That's the purpose for a nested loop, where we want to use them. It's a method. It's not the most preferred method, but it is a method. And if that's what you have to do at first, you can do that and then refactor later. There's nothing wrong with that. Sometimes it's best to kind of just start coding and get some functionality going, right? Putting some things on the screen and kind of see what's happening here. And that's why you have your terminal, these tools like VS Code and actively see what our code is doing. Go ahead and code that nested loop. See what it's doing. If you're on the right path to reach the outcome you're trying to reach, right? There's no point in getting so wrapped up and like I want to avoid nested loops and have horrible efficiency, and then you don't even get started, right?
That's
Put
where
some
I'm at.
code. Yeah, so that helps. Like just forget about that at first. Put some code on your screen, right? Get some stuff going on there. Start checking what your code's doing. Okay, I see. I'm getting an outcome. Now let's see if there's a better way of doing this instead of using the nested for loops. But it's okay. Like there's nothing wrong with just putting some stuff on the screen first to ensure you can start visualizing the problem and the solution. Right? It can get very complex when you're trying to just solve it in your head. Sometimes you kind of want to start seeing things on screen to kind of get an idea of what you're supposed to do. Right? This is a very simple problem description. There are some problems out there that can get very confusing just by reading like, what in the heck am I supposed to do? Like, okay, so I'm supposed to do this, take that, screw all that, put it on your screen first, right? Get the variable, start messing around with the list, the whatever nums you're supposed to be taking, kind of arguments and whatnot. It's to kind of start seeing what you're supposed to do. Because if you try to start, coding in your own head and figure out the solution in your head, you're gonna lose yourself. And it's always good to kind of like, make some comments out, like, what am I supposed to do? Well, let's see. I have to take a list of positive integers, a number called num. The function should calculate the maximum sum of a consecutive elements in the list. So I need to create a window, right? What's next? Maybe figure the current sum that I have. Once I have that, initiate a for loop. Set conditions to check. If the next sum is good, right? Second, to check new sums. And kind of start putting some notes on there, and then kind of start doing that, right? Okay, well, what's my current window? I can create that window. I didn't use the window here specifically where I saved the variable. But I mean, I guess you can say I did, using the max sum, right? Get that for loop going, get something here, kind of break it down into smaller, digestible steps that makes it easier to take in. When you're just reading the description and trying to understand all these steps, sometimes it's better to, instead of focus on the 300-meter target, focus on the first 25 and 50-meter targets. Get some stuff on there. And then once you hit the first 25 and 50, you can start worrying about the 200, the 250, and 300 over time, right? But you're not gonna get nowhere if you just don't put some code on there. So it's okay to start with some nested for loops if you have to, right? Where are you guys getting lost?
I got lost, so basically, I think I'm still, well, you didn't even use a while loop. So I tried doing it, with the binary search-ish way. Trying to use, like a while loop, and then I feel like I'm creating too much complexity by using for index in range. But then I see that you do it. So that's the part where I'm confused on. It's like,
You could use a while loop and just say while the whatever index does not reach the end of your list, then continue checking. You can. It's just
That's how I did it.
ensuring that
And-
you add the functionality for the condition so you don't have an infinite loop. Cody, do you want to demonstrate what you have?
Yeah, sure. I mean, the way I did it was actually I'll start sharing first. Share. All right. So created the class, of course, and this was just a test right here. And then I thought of it a little different. I figure if there's any numbers in there, then that counts. Like I didn't realize that it had to be the actual length for it to actually count. That's how I interpreted it. But I said if not slider size, then slider size equals 1. And then if the length of the number listed is equal 0, then just return none. Then here I just put left, right, and max sum. So left is equal to 0, right is the slider size minus 1, and then max sum is equal to 0. And that actually handles the case if there's only one item in the list, so that would automatically return that. Then I just put while right is less than or equal to the length of numList minus 1, and then I just had the local max equals to the sum of that numList with the left and the right index, right plus 1 index, and then 1 to iterate once through. And then I just, if max sum was less than local max, I set it, and then I did left and right plus 1. And so, how do I get the terminal back up?
Control and then the key to the left of 1, which is the squiggly line.
Okay. Said it wasn't it.
It wasn't?
Oh, that was, sorry. Okay, I got it. I was pushing, I'm on a Mac.
Okay.
So Python sliding window, and then ended up coming out. So Brendan, the same thing with you. Like I was getting confused on what should be here, -1 +1, and I literally just played with it. I had this print out here, numList left, print right, local max. So my right actually goes outside of the loop, or used to. Actually, I could probably print numList right, but I used to get the, let me see if it's up here, the out of range error right here, right? Numlist right is index out of range. And I just played with it until I didn't get that. And then I added another max sublist sum just to check a couple of other things, but then I deleted it. But then that's how I ended up figuring that out. So, so yeah, that's what I did with my code. Any questions on that?
No, yeah, pretty standard. You created that window on line 29. That's, I did a little bit different, but same, but different.
Mm.
But yeah, good job.
Okay.
You're able to use that while loop, Brandon. There's no specific way of going about it. Up to this point, you guys probably should have already kind of caught on to that. Is there's no right or wrong way. There's different ways of skinning the cat. It's okay to start one way, refactor it, and make it better. There's nothing wrong with that. Different ways will reach the same outcome. Some are more efficient than others. But you guys don't have to be perfect right now. You don't have to have the fastest code and the cleanest code. That comes with time, all right, with time experience. The important thing is to get some code on screen, right? I mentioned that when we first started off is, you're not going to learn coding unless you're behind your computer screen, putting some code on the screen. And that's the first step, right? It's kind of like, going to the gym. People talk about, oh, I don't know what to do, all these workouts. There's so many workouts, right? There's so many functions we can do, so many methods we can use. I just don't know where to start. Well, the first step is getting into the gym. The first step is being on behind your screen and putting some code on there. And then with time, you'll get better. You'll figure out what works, right? Just like working out, you'll figure out which workouts work best for whatever hits what muscle groups. Same thing with code. You figure out, which methods work best, all right, how to code it, and it becomes easier over time. It's a trial error at first, right? Because you don't know. There's so many ways of doing things. But as you learn and you gather more experience, you do your research, and you find ways to improve, you slowly begin to realize that there's much more efficient ways of doing things and better ways of doing things, faster ways of doing things. So it's a process, but it starts with just putting some code on the screen. All right, so don't get too overwhelmed. Dissect it if needed. Break it into smaller chunks that are easier to digest, so you don't feel overwhelmed. All right. Yeah. So that's going to conclude lesson 11. Next lesson is going to be finish. I don't know what it says. Finish. Searching, sorting, and recursion. It's going to be other types of algorithms and data structures. We're not going to start it today because I would hate to have to cut halfway before even reaching the first assignment. But good job on you guys for showing up today. I really appreciate it. I like when we get, a bigger class in here. I hate when it's just like 3 or 4 of us. But definitely do check out that Grokky's algorithm. Data structures, data algorithms, Brandon, and for anybody else that feel like they're struggling with it, it is its own art, right? I've mentioned before, it's different than software developing, and it's not going to be tested, so you don't have to stress about it. But it is going to be your biggest gate to get through for a job application. So you don't have to be perfect for now, but get better at it over time. Try out different problems. There is a nice little path. Have you guys heard of the Blind 75?
Yep, I'm working on that currently.
Yeah, the Blind 75. We're gonna work on it at the end of the course. Kind of start doing some other stuff that isn't on the assignments. But the Blind 75, someone took the time and figured out what are the most commonly seen problems in tech interviews, right? And they took 3 or 4 problems from all different types, right? Whether it's like using the sliding window, using 2 pointers, dynamic programming, using hash maps. They took linked lists, which you'll figure out later on. They took all these different types of essentially subjects of different ways of, different algorithms to solve different problems. And they got the most commonly seen problems in tech interviews that use these data algorithms. And they created a small little like crash course, essentially like, hey, if you want to study out for your next tech interview, solve all these problems, and you should have a general idea. You become pretty much a jack of all trades if you're able to finish the entire 75 problems. You'll know a little bit of everything, enough to kind of get by through an interview. The Blind 75, we have, or there is, a this pretty cool guy on YouTube. It's called Neat Code. Have you ever seen that YouTube channel? I'm go ahead and share my screen. He has a website called Neat Code. The default page looks like this. It'll bring you to this area. You can sign in using your GitHub, but he has a roadmap. You can click the roadmap, and he has from start to finish. This is not accurate. I've done more than this, but I have it on the LeetCode actual website. I went to the LeetCode website. They have a blind 75 there too. But at first, I started off here. And it starts off with simple stuff like arrays and hashing, right? And you can solve them. They have different difficulty. They have video solutions. And then you can just check them out as you complete them. And you work your way down through the tree. On leetcode.com, they have something very similar to. Oh, let me sign in real quick. Can't let you guys know what my stuff is. Don't want to get hacked and you guys solve the problems for me. I would hate that. Let's see. Okay. Wrong email address. What the heck is going on? I don't know what's going on with my account. I can't sign in. But on LeetCode, you're able to do the exact same thing. Can I sign in with GitHub? Oh, I do. Okay. If you go to problems, they have a wide range of different stuff. You can see the top interview 150. You can see the LeetCode 75, which is very similar to the blind 75. And then they'll have the problems for you from start to finish. I've done a little bit of multiple sections, as you can see. But you can come here and you can start from the very top and work your way down, right? Some of these, even though they say they're freaking easy, that's a lie. But try your best. Try to solve a couple of them. If you get through them, move on to the next section and whatnot. They're a great way to start off for
You have to
coding
pay for
interviews.
this list?
For this right here, no. You just make an
Okay.
account. They have it. If you go to problems, they have study plans. Is what they're called, right? 30
Okay,
days
and
of JavaScript. What's up?
are you a premium subscriber though?
Heck no, man.
Okay,
I'm poor. So I ain't paying for nothing. But yeah, you can come to LeetCode and they have certain little study plans like this, all types too, man. Like open it up, LeetCode 75. These are the most common ones. 30-day challenges for, I don't know what pandas is, but for JavaScript, if you struggle with JavaScript, cracking code interviews, they have different ones. They have obviously the premium ones. I ain't doing no premium one. Go to the free ones. They have a lot of stuff, in-depth topics, right? Dynamic programming, binary search. But come here, check it out. And if you go to some of these, we'll open them up. Let's go to the LeetCode 75. We'll go to a simple one like container with most water. This was actually a little confusing. They can get very difficult, but you can go to solutions. They'll have the different solutions. You can filter it out by what language you're using. So Python 3 or whatnot. And they'll show you the best method. Typically, you'll see the at the very top how many people have seen it, upvotes, right? You can click it, and they'll have an explanation step by step of how it was done. You can check your previous submissions. Click it here. My runtime was absolute garbage, right? But it'll show you the runtimes typically, and then it'll show you how many solutions were in that bracket. Mine was pretty slow, as you can see. The fastest was up here, but only 1.97% of the solutions were this fast. On average, most of these were right here. And then you can see what the solution was of how fast those were, and it shows you what they were. So very, very cool. let's check out some other ones, preferably one that I did really good on. Solutions, submissions, accepted. Look at that, boom. Obviously there are better ones, but yeah, so you can see your runtimes in one nap. But if you want to get better, check these out. Pretty cool. And then once you start a study plan, you can see it on the left side, all of them. Yeah, pretty interesting. I will give you guys some homework. See if you guys can do this one. This one was pretty interesting. Given an integer array height 11, there are n vertical lines. You have to find which combination of these will have the most water. Right? Which one can have the most water? And it varies depending on how far away they are from each other and how tall, right? The tallness is referencing to how big the number is. The length is how far away they are from each other in the array. This one was actually very complex, but this one was a very interesting one. Check those out. But yeah, those are ways of getting better and whatnot. If you don't like LeetCode's plan, the roadmap was very helpful, right? It's the same thing, like say Valid Palindrome. It takes you to a little kind of IDE, and they have their own version. It's very similar to LeetCode, a little bit more simplistic. But yeah, man, these are some resources you can use to get better at it. Here is a pro tip. Don't spend 2-3 hours on one problem. Do not do it. You're gonna waste your time, right? Tips for getting better. You should set a timer. When you start a new problem, set a timer on your screen, 20-30 minutes max. Once the timer runs out, check the solution. Do not break your head for 2-3 hours and waste 3 hours of your life on one problem. If you don't know what you're doing, if you reach past 20-30 minutes and you don't understand the problem, you're wasting your time. Check the solution, learn the algorithm of how to solve it, right? And then try to implement it, right? Try to recreate it, learn it, study it, go back, and then try to do it yourself. Because obviously, if you're going in there and it's something you're not used to, how to use, sliding window, 2 pointers or whatever, if you don't know the algorithm, it's hard to implement it, right? You're not just going to learn the algorithm by typing in random code, hoping you learn how to think critically in that manner. Check the solution. Set that timer, 20-30 minutes tops. Try to figure it out. If you can't, check solution, learn from it, get better at it, bookmark it, come back to it later, the next day. All right, see if that information stuck, right? That's the best way of doing it. Do not spend 2 or 3 hours on one problem. You're going to waste your time. Cool? That's all I'm going to leave you with. I'm going to stay here behind for another 10 minutes if anyone has any questions. But besides that, thank you guys for showing up. Thank you for your contribution. And I will see you guys next week. No class tomorrow. All right, next week, Monday. Cool?